Take a single sheet of paper, fold it in half. Now imagine doing that just 42 times. That stack of paper would reach the moon. Not halfway, not close, all the way there, 239,000 miles into space, from your desk, from one sheet of paper. You don't believe me? Good, you shouldn't, because everything about this feels wrong. A piece of paper is thin, laughably thin, about 1/10 of a millimeter. You could stack 10 sheets and barely cover a fingernail. So how could 42 folds possibly escape Earth's atmosphere, cross the void of space, and touch the lunar surface? Let's start small. 1 fold. You've doubled the thickness. Now it's 2 layers. Fold again. 4 layers. Again. 8. Nothing impressive yet. After 10 folds, how thick do you think it is? Take a guess. Most people say a few centimeters. Maybe the width of a finger. The real answer? After 10 folds, your paper is thicker than your hand. It's about 10 centimeters tall. That's already surprising. But we're just getting started. 20 folds. Now guess. A meter? 2 meters? Try 100 meters. After 20 folds, that paper is taller than a 30-story building. We started with something you could blow off a table, and in 20 doublings, it towers over a skyscraper. But here's where your brain really starts to break. 30 folds. That stack is now 100 kilometers tall. You've passed the edge of space. You're above the International Space Station. Astronauts are looking up at your paper, and we still have 12 folds left. 42 folds. 439,000 kilometers. You haven't just reached the moon. You've overshot it. That single sheet of paper, folded 42 times, extends past the moon and keeps going. So why does this feel impossible? Why did every estimate you made turn out to be wildly, embarrassingly wrong? Because your brain evolved to think in straight lines. When something grows by adding 1, 2, 3, 4, you can feel where it's headed. But when something grows by doubling 2, 4, 8, 16, your intuition collapses. Doubling is quiet at first. It feels slow. It feels safe. And then it explodes. This isn't just a paper trick. This pattern runs underneath everything. Put a penny in a jar and double it every day. After a week, you have 64 cents. Boring. After a month, over $10 million. That's compound interest, the same force that builds fortunes and drowns people in debt. One person catches a virus. They give it to 2 others. Those 2 give it to 4. In just 30 doublings, that single infection becomes a billion cases. That's not science fiction. We watched it happen. Think about computing power. Your phone is millions of times more powerful than the computer that landed astronauts on the moon. Not because of one breakthrough, because of decades of quiet doubling, year after year, each step small enough to ignore, until suddenly your pocket holds more processing power than entire nations had a generation ago. Artificial intelligence is on this same curve right now. Every year, capabilities double. And just like the paper, the first 20 folds look boring, unimpressive, easy to dismiss. But somewhere around fold 25 or 30, the world changes overnight. Not because the force is new, but because we finally noticed it. This is the great trap of exponential growth. It's invisible until it's undeniable. It whispers for so long that when it finally screams, everyone acts surprised. So here's what I want you to take with you. The most dangerous phrase in a world of doubling is, it's only a little more than yesterday. Because the moon isn't 42 giant leaps away. It's 42 doublings away. And each one looks exactly like the last. Right up until it doesn't.